Question 108, convert sorted array to binary search tree. Given an integer array nums where the elements are sorted in ascending order. So an array of integers is given to us and these numbers are sorted in ascending order. The question is asking us to convert this array to a height balanced binary tree. So what is a height balanced binary tree? Is a binary tree in which the depth of two subtrees of every node never differs more than 1. So as you see, like this is a completely height balanced binary tree. But if we had another node here, like from the right side of -3 node, it was still height balanced binary tree because the difference was only 1. But if we had one node from -10, then it wasn't a height balanced binary tree. So, and also the question is saying if we return the height balanced binary tree like this or like this, they are both going to be accepted. This is another example. It says 3, 2, 1, 1, 2, 3, they are both accepted as long as it's the height balanced binary tree. When we talk about graphs, binary trees, and these sort of like traversing, first thing that comes to our mind is BFS or DFS for traversing tree or an array to build a tree. There are different ways that we can traverse DFS. It's going to be pre-order, it's going to be in order, and it's going to be post-order. So in this question, what we are going to do, we are going to use DFS to traverse this array and build those tree. First thing that we are going to do, we are going to check if nums is not empty, and if it is empty, we are going to return none, right? If the nums is empty, we are going to return none. Then what I'm going to do, let me explain it using this example. So what I'm going to do, I'm going to find the middle of this array and build a node from it and use the left side for building the left nodes for that root, and using the right side to building the right nodes of that root. And I'm gonna use a recursive function to recursively call this function and make the left side and right side. Let's see how we can do that. First thing that I'm going to do, I need to find the middle number. So it's gonna be the length of nums divided by 2 because we don't want a float number, right? So for example, for this one, m is going to be, length is going to be 5. It's 1, 2, 3, 4, 5. 5 divided by 2, it's gonna be 2, right? So it's gonna be index 0, 1, 2. So 0 is going to be the root node. So let's make that. I'm going to say root is equal to, I'm going to call this class here. So it's going to be 3 node, and what it needs a value. I'm going to give the value to it. I'm going to say nums at index m, right? And then I need to make the left nodes and the right nodes. For doing that, I'm going to say root.left, and I'm going to say root.right, right? So what I'm going to do, I'm going to call this function recursively, but this time I'm going to call the function for the left side of the value that we use for the root, for the root.left, and right side of the value that we used, the right side of the root value, right? So what I mean by that, I'm going to say self, I'm going to call the function itself sort pet array, hopefully we don't have typo, bst, and I'm going to give, instead of nums, I'm going to give from the root node to the beginning. So it's gonna be to the end because this is exclusive, so m is not going to be included. And I'm going to do the same thing, sorted array to bst, hopefully no mistake or typos, and I'm going to say nums from n+1 to the end, right? So this is how it works. And then what I'm going to do, I'm going to return root as a result. So let's see what happens. So after making the root, which is going to be 0, what will happen? I'm going to say what is built so far. So 0 is built. I'm going to call this function. When I call this function, it's going to be called for -10 and for -3, right? And then it comes here, it divided by 2. The length is 2 divided by 2 is going to be 1, so it's going to be -3. So it builds the -3 one, right? And it reaches to here, it needs to build the left node again, so it will call this function and it will call the -10 one only, right? It calls this one, it comes here, divided by 2 is going to be 0. 0, it's the -10 one, so it's going to build the -10 here. And what it does, now it's going to be an empty, right? So what it happens, it comes here and the nums is empty, so it's going to build 9 here, right? And then we are using a stack because we are calling this recursively, right? So it goes all the way back after this is done, and it's going to start to build the right side, 5 and 9, and then it's gonna build 9, and then it's gonna build 5, and then it's going to be empty, right? So this is how it's happening, and it builds the tree. This was just for illustration purpose, so you can better understand. Let's run the code and see if we don't have any mistake or typo. And there you go, it was accepted. So the time complexity for this is linear because we need to go through every single item that we have in here. And the space complexity, because we are using recursive stack, is gonna be logarithmic. Thank you.